Hello, space enthusiasts and curious minds alike. Welcome back to our channel. Today, we dive deep into a groundbreaking discovery that has everyone talking. The James Webb Space Telescope, a marvel of modern astronomy, has recently made a startling find on the exoplanet K2-18b, located 120 light-years away. But as with all great discoveries, there's a twist. Stick around as we uncover the signs of life on K2-18b and explore the challenges that come with it. However, the true star of the show is K2-18b. This planet has been thrust into the limelight thanks to the James Webb Space Telescope's groundbreaking observations. The surge in interest around K2-18b is fueled by recent studies of its atmospheric makeup, which have unveiled some extraordinary results. Notably, the presence of methane stands out, hinting at the exciting possibility of life, as methane can be a biological signature. Moreover, the atmosphere of K2-18b shares some striking similarities with Earth's, featuring an abundance of carbon dioxide and a conspicuous lack of carbon monoxide. Yet, the most electrifying discovery is the potential detection of dimethyl sulfide, DMSA, gas typically produced one day, a confirmation of life beyond our own world. Is K2-18b a habitable oceanic exoplanet? Or do alternative theories better explain the data from the James Webb Space Telescope, JWST? According to density measurements, K2-18b could potentially harbor vast oceans under a thick, hydrogen-rich atmosphere, keeping its waters slightly warmer than Earth's. This places K2-18b intriguingly between a super-Earth and a sub-Neptune, aligning perfectly with the characteristics of an ocean world. The presence of methane in the atmosphere adds a layer of intrigue. Methane is a volatile compound that typically dissipates within a few years under the assault of solar radiation, suggesting that some continuous source is replenishing it. This phenomenon raises the tantalizing possibility of life, indirectly hinting at biological processes at play. However, caution remains our watchword. Researchers from NASA Ames Research Center and the University of Washington have taken a rigorous approach, employing two distinct models using JWST data to unravel this mystery. The first model assesses rocky planets with surface oceans, both with and without biological influences. The second evaluates gaseous planets devoid of a solid surface and life, focusing on the planet's photochemistry, which involves chemical reactions triggered by photons from its star and its climate. These models help parse the complex atmospheric data, offering insights that temper our excitement with scientific rigor. As the team delves deeper into the data, the nature of K2-18b continues to enchant and challenge our understanding of what makes a planet potentially habitable. K2-18b challenges the notion of being a mere lifeless water world. Why? Despite the allure of this hypothesis, it's important to temper our enthusiasm. Research indicates that a model of K2-18b as a gas-rich, uninhabitable exoplanet also correlates well with the JWST findings and presents fewer scientific discrepancies. The ocean world hypothesis not only requires the presence of life to account for its methane levels, but also faces significant hurdles in maintaining a cool surface temperature necessary for life, given the potential for a runaway greenhouse effect. This suggests that the planet might be too warm to support life, prompting researchers to recommend that any search for life on exoplanets should prioritize verifying that their temperatures are conducive to hosting oceans. So, the mystery of K2-18b remains neither the life-bearing ocean world nor the sterile gas giant model completely fits all the observed data. Future observations from JWST may tip the scales, potentially revealing the presence of ammonia, which would point towards a gaseous planet, or dimethyl sulfide, DMS, which would bolster the case for biological activity. This ongoing exploration keeps the scientific community on the edge of their seats, eager for what revelations may come next. Is K2-18b more likely a watery haven or a colossal gas giant? Dive into the debate and share your thoughts in the comments below. Now, let's shift our gaze to another exoplanet that's like something out of a science fiction nightmare. Welcome to WASP-76b, an exoplanet that's so extreme it's been described as downright hellish. Some astronomers even label it terrifying. Orbiting perilously close to its star, this planet endures temperatures high enough to vaporize lead. Yet, amidst these scorching conditions, astronomers have recently added an unexpected adjective to describe it: glorious. Discovered in 2013, WASP-76b orbits its yellow-white main sequence star WASP-76, which is about 1.5 times more massive than our Sun, at just 48 million kilometers away. For comparison, this is far closer than Mercury is to our Sun. Imagine the scorching heat. But here's where it gets interesting. What if one day, as a spacefaring civilization, we decided to visit WASP-76b, located only 637 light-years away? What marvels might greet us upon arrival? Well, for starters, the extraordinary conditions on this glorious hell of a planet would be nothing short of a spectacle. So, what do you think about these extreme worlds? Could K2-18b be an oceanic retreat, or is it more likely a gaseous behemoth? And as for WASP-76b, terrifying, hellish, or gloriously fascinating? Let's explore these cosmic mysteries together. Drop your thoughts below. Imagine a planet where the day is not just sunny but blisteringly hot, and the night rains iron. Welcome to WASP-76b, a planet that redefines extreme. This giant is tidally locked to its parent star, which means one side perpetually faces the star, bathing in continuous daylight, while the other side is shrouded in unending darkness. On the day side, temperatures skyrocket to over 2400 C, hot enough to vaporize iron. Yes, on WASP-76b, iron doesn't just melt, it turns into gas. But the spectacle doesn't end there. The planet's fierce winds whisk this iron vapor over to the cooler night side, where it condenses back into liquid form and precipitates as iron rain. Imagine skies where raindrops are molten metal, a phenomenon as mesmerizing as it is terrifying. Amid this otherworldly weather, astronomers have observed something truly spectacular, a phenomenon known as glory. This effect, akin to a rainbow, creates colorful concentric rings of light. Such an atmospheric spectacle is seen on Earth and was once observed on Venus, but finding it elsewhere in the cosmos is rare. It requires very specific conditions: atmospheric particles that are nearly perfectly spherical, uniformly sized, and exceptionally stable. WASP-76b is not just another exoplanet. It's a testament to the universe's ability to surpass even the wildest imaginations of science fiction. It's a stark reminder of the beauty and terror that can exist beyond our earthly confines. The discovery of a glory on WASP-76b could fundamentally alter our understanding of ultra-hot exoplanets. This rare and delicate atmospheric phenomenon requires precise conditions. The planet's nearby star must illuminate it directly, and we must observe it from just the right angle. In this grand celestial theater, our role as the observer is played by none other than the European Space Agency's dedicated exoplanet mission, known as CHEOPS, Characterizing Exoplanet Satellite. Over 3 years, CHEOPS closely monitored WASP-76b, conducting nearly 24 observational campaigns. Scientists were particularly captivated by an unusual asymmetry in the light patterns emanating from the planet's outer atmosphere during its transits. These moments revealed a striking variation in light intensity along the planet's eastern terminator, the sharp line where its blistering day side meets the frigid night side. Researchers suggest this marked change in brightness could be due to a pronounced directional and reflective effect, which they've termed the glory effect. Despite the surrounding tumult of a planet where metals vaporize and rain, this subtle signal of glory, though faint, has been detected. It's an incredibly faint signal, noted a scientist from ESA, underlining the delicate balance and specific conditions required to witness such a spectacle. This discovery not only highlights the extraordinary capabilities of missions like CHEOPS, but also deepens our intrigue about the dynamic and often extreme environments of distant worlds. It reminds us that even in the chaos of a planet as harsh as WASP-76b, there are still phenomena of exquisite beauty to be observed and understood. Why is the glory effect on WASP-76b such a groundbreaking discovery? The presence of this atmospheric phenomenon on such an ultra-hot Jupiter suggests that there could be clouds composed of perfectly spherical water droplets. Remarkably, these clouds seem to have either persisted for at least 3 years or are being continuously replenished. If these clouds are indeed stable, it implies that the temperature within WASP-76b's atmosphere, despite its extreme heat, remains relatively consistent. This revelation points to an unexpected stability in an environment previously believed to be wholly chaotic. These insights open exciting new avenues for exoplanet research. Scientists might now explore other distant worlds for similar optical phenomena, like starlight reflecting off potential liquid lakes or oceans. Such discoveries are pivotal in our ongoing quest to uncover life beyond our solar system. The James Webb Space Telescope, known for its advanced observational capabilities, has detected what seems to be signs of life on K2-18b. However, its atmosphere is thick enough to potentially shield any residing life forms from these harmful rays. This makes K2-18b a unique study subject, as its conditions challenge our understanding of life's adaptability in the universe. However, there's a significant hurdle. The signs of life are not definitive proof. They could be the result of non-biological processes that mimic the signatures of life. Further complicating matters, the high radiation levels and extreme atmospheric conditions on K2-18b make direct exploration and data collection exceedingly difficult. To address these challenges, several future missions are being proposed. These include advanced robotic probes designed to withstand the harsh conditions of K2-18b. Scientists are also developing more sensitive instruments that could be deployed on the James Webb Telescope to gather more conclusive data. The potential discovery of life on K2-18b opens new doors for astrobiology. It challenges us to redefine our criteria for habitable worlds and expands our search for life beyond the traditional confines of Earth, like planets. This discovery could potentially alter our understanding of life in the universe, making it one of the most significant finds in the history of space exploration. The discovery of potential life on K2-18b raises ethical questions about our responsibility as explorers of the cosmos. How should we proceed in our quest to study this distant world? Should we prioritize the preservation of any potential life forms, even if they are microbial? These are complex dilemmas that require careful consideration as we navigate the frontier of space exploration. The news of possible life on K2-18b has sparked widespread interest and excitement among the public. People around the world are captivated by the idea of discovering life beyond Earth and eagerly await updates on this developing story. This renewed enthusiasm for space exploration highlights the universal human desire to understand our place in the cosmos. In the pursuit of unraveling the mysteries of K2-18b, international collaboration is key. Scientists from various countries are coming together to share resources, expertise, and data in order to maximize our understanding of this distant world. Collaborative efforts like these exemplify the spirit of cooperation that defines humanity's quest for knowledge. The exploration of K2-18b is pushing the boundaries of technological innovation. From the development of next-generation telescopes to the design of advanced spacecraft, scientists and engineers are continuously pushing the limits of what is possible. These technological advancements not only enable us to explore distant worlds, but also drive progress here on Earth. The discovery of potential life on K2-18b reignites interest in the search for extraterrestrial intelligence. Scientists are reevaluating existing SATI programs and proposing new strategies for detecting signals from intelligent civilizations beyond our solar system. The prospect of making contact with another civilization is both exhilarating and humbling, reminding us of the vastness of the cosmos and our place within it. The potential confirmation of life on K2-18b would have profound societal implications. It would challenge religious, philosophical, and cultural beliefs about humanity's place in the universe. The discovery could also inspire a renewed sense of unity and purpose among people worldwide, as we come to grips with the notion that we are not alone in the cosmos. Studying the conditions on K2-18b offers valuable insights into environmental sustainability on Earth. The extreme conditions present on the exoplanet serve as a cautionary tale, reminding us of the fragility of our own planet's ecosystem. By understanding how life might adapt to such harsh environments, we can gain new perspectives on how to better care for our own world. The discovery of potential life on K2-18b presents exciting educational opportunities for students of all ages. It ignites curiosity about astronomy, biology, and the search for extraterrestrial life. Educational institutions around the world are incorporating this discovery into their curriculum, inspiring the next generation of scientists and explorers. Throughout history, humanity has looked to the stars with wonder and awe. The discovery of life on K2-18b is a testament to our innate curiosity and desire to explore the unknown. It serves as a reminder of the power of human imagination and the endless possibilities that lie beyond our own planet. As we continue to study K2-18b and search for signs of life, we must also consider our ethical responsibility to any potential inhabitants of the exoplanet. We must approach our exploration with humility, respect, and a commitment to preserving the integrity of this alien world. Our actions today will shape how future generations perceive our role in the cosmic tapestry. The quest to understand the potential life on K2-18b drives scientific advancement in various fields. Researchers are developing new techniques for analyzing exoplanet atmospheres, refining models of planetary habitability, and pushing the boundaries of astrobiology. Each breakthrough brings us closer to unraveling the mysteries of this distant world and the potential life it may harbor. The discovery of potential signs of life on K2-18b reignites discussions about the feasibility of space colonization. While the exoplanet presents challenges, such as its high radiation levels and extreme conditions, it also offers tantalizing opportunities for human expansion beyond Earth. This discovery sparks imaginations and fuels debates about the future of humanity in the cosmos. The exploration of K2-18b captures the public's imagination and encourages engagement with science and exploration. Citizens worldwide follow updates on the mission, participate in citizen science projects, and engage in discussions about the implications of the discovery. This widespread interest fosters a sense of connection to the broader scientific community and inspires future generations of explorers. The discovery of potential life on K2-18b prompts discussions about the possibility of interstellar communication. Scientists contemplate ways to send messages to any potential inhabitants of the exoplanet, pondering the universal language that could bridge the gap between civilizations separated by vast cosmic distances. This speculation highlights humanity's desire for connection and understanding across the cosmos. As we reflect on the discovery of potential life on K2-18b, we are humbled by the vastness and complexity of the universe. It reminds us of our place as explorers in a vast cosmic ocean, seeking to unravel its mysteries one discovery at a time. The journey of exploration is as much about the questions we ask as it is about the answers we find, filling us with wonder and awe at the beauty of the cosmos. As we venture further into the unknown reaches of space, it's crucial to consider the ethical implications of our actions. Exploring K2-18b and other distant worlds requires careful consideration of the potential impact on any indigenous life forms and their ecosystems. We must strive to be responsible stewards of the cosmos, respecting the autonomy and integrity of all planetary environments we encounter. The discovery of potential life on K2-18b resonates deeply within the cultural fabric of humanity. It sparks conversations about our place in the universe, our shared origins, and our collective destiny. Artists, writers, and creators draw inspiration from the cosmic wonder of the discovery, enriching our cultural landscape with new visions of the cosmos and our place within it. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.